Hi kids, welcome to a new weekly science lab video. We're moving on. Let's get into the basics of applying scientific knowledge to everyday life. It's time to dive into the exciting world of technology. Let's talk about simple machines. A simple machine is a device that makes work easier by changing the direction or the intensity of a force, which means that they allow us to do work with less effort. Simple machines have been used since ancient times to facilitate, among other things, the building of great monuments that have lasted until today, and that, if it were not for them, would never have existed. Although they had already been in use for a very long time, the Greek scientist and inventor Archimedes was the first one we know of, some 2,200 years ago, who studied simple machines as such. He identified three simple machines: the lever, the pulley, and the screw. This time we'll focus only on the lever. Archimedes explained that levers provide a mechanical advantage, meaning that using them would allow a person to move something that would normally be too heavy to move. On one occasion, he reportedly went so far to say,
"Give me a lever long enough and a fulcrum on which to place it, and I shall move the world."
That's all well and good, but what's a lever? And what in the world is a fulcrum? A lever is a tool like a rod or a bar that rests on a fixed support called a fulcrum. When a lever is used, a small force is applied over a long distance, and the lever turns it into a larger force over a shorter distance. Three types or classes of levers can be distinguished, which simply differ from each other in the relative position of the fulcrum and the applied force with respect to the resulting force. Thus, Class 1 levers are those in which the fulcrum is placed in a central position with respect to the applied and the resultant forces. An example of this type of lever would be a seesaw. If we duplicate the lever, we obtain something like a scissor. Class 2 levers are those in which the resultant force is in a central position with respect to the applied force and the fulcrum. An example of this type of lever would be a wheelbarrow. If we duplicate this kind of lever, we obtain something like a nutcracker. Class 3 levers are those in which the applied force is in a central position with respect to the resultant force and the fulcrum. An example of this type of lever would be a shovel. If we duplicate this kind of lever, we obtain something like a tweezer. In this image, you can see that there are many more examples of levers of each class, and if you stop and think about it, we are really using levers of all three classes continuously in our day-to-day. At this point, we can talk about the so-called law of the lever. It is actually very simple. Basically, it says that the proportion between the intensity of the applied force and the resulting force is equal to the proportion between the distance separating each of these forces from the fulcrum. To simplify, we will call LA the distance separating the fulcrum from the point where we apply the force, and LR the distance separating the fulcrum from the point where the resulting force occurs. Well, this law says that the longer LA is with respect to LR, the greater the resulting force, FR, will be respect to the applied force, FA, and vice versa. This can be expressed mathematically in the following way. In other words, we can say that the work of each of the arms of the lever is the same. Here we are using the concept of work in scientific terms. Thus, work is defined as the product of multiplying a force times a distance. In this case, the force effected on a certain arm of the lever times the distance separating it from the fulcrum. It's not that difficult, right? Let's put it to test. Roll up your sleeves, for it is experiment time. Just find an example of a lever from each class, which I'm sure you have several in your house, and experiment with them. Identify their fulcrum and where the applied and resulting forces take place. Test the law of the lever. Do the math to see if it is true. Make a lever with a stick of any length and find a support point that serves as a fulcrum. Place the fulcrum in such a way that you establish a class of lever, and then change the distances between the forces and the fulcrum by moving the load closer or farther from it, and by moving the point where you are applying the force closer or farther from it as well. Remember that since we are talking about forces and weight is 1, we must know the mass of the load and multiply it times 9.8 meters per square second. Remember that is the acceleration due to the gravity on the Earth. Once we know the weight of the load and the measurement of the distances to the fulcrum, we can simply find out what the value of the applied force is by dividing the work in the arm of the resulting force by LA, the distance between the applied force and the fulcrum. In this way, we are mathematically calculating something that we can also appreciate empirically by experimenting with the levers ourselves. Attached to this task is another video to delve a little deeper into the law of lever. I look forward to seeing your creativity at work with those levers. I hope you enjoy this activity. See you!